The RSA 5000 is a high-performance sweeping analyzer. This means that in addition to real-time monitoring of the spectrum for transient signals, the RSA 5000 is also a great choice for verifying RF components and functional blocks within a design. Devices of interest that often need characterized or verified within a transceiver setup include antennas, filters, mixers, amplifiers, and phase lock loops. Many of these components are best characterized using a spectrum analyzer with a tracking generator. High-performance specifications including low phase noise, displayed average noise level, internal preamplifiers, and more resolution bandwidth settings are also important to being able to confidently verify a design's performance. In sweeping mode, the RSA 5000 provides typical performance usually reserved for the highest performing instruments, including 1 Hz RBW, displayed average noise level as low as minus 165 dBm, and phase noise as low as minus 108 dBc per hertz. Let's look at a few of these standard tests and how they are conducted with the RSA 5000. First, let's use the VISWAR measurement that is standard with the RSA 5000-TG models to characterize an antenna. With this automated VISWAR measurement, we can tune or verify our antenna to optimize range and battery life for our transceiver. Here, we're using a VB1040 directional coupler accessory to make the measurement. Next, let's measure an amplifier. First, we measure the power of a fixed signal without the amplifier and have frozen that in green. Now, we can connect our amplifier, turn that on in another trace, and we can see the difference, the output, the amplification at the center frequency of 950 megahertz. Additionally, we can use the markers to set up a delta marker and see the 23 dB difference generated by the amplifier. So that's an easy way to calculate the gain of the amplifier at this frequency. Here, we've switched to a filter on our same 950 megahertz transceiver set. Here we're looking at the shape of that filter over the 100 megahertz, right around 950 megahertz. So in addition to the shape, we can also easily go into the marker functions and look at the 3 dB bandwidth of that filter. Here it's about 40 megahertz. So that gives us a nice wide band in our transceiver with a fairly flat output. Common mixer parameters, including conversion loss and LO phase noise, are easily measured using the standard markers and noise measurements. With the addition of the Advanced Measurement Kit option, the RSA 5000-AMK, we can simplify more complex measurements, including third-order intercept measurements shown here. The RSA 5000 is also capable of going beyond these component parameters. The AMK option also includes complete transmitter or system test configurations, including total power, channel power, adjacent channel power, occupied bandwidth, emissions bandwidth, carrier noise ratio, and harmonic distortion. The RSA 5000-PA preamplifier option improves noise performance capabilities on many of these component tests as well. Finally, real-time mode includes an automated measurement for hopping 2FSK modulations. Once your component verifications are complete, real-time provides 7 different ways to visualize RF signals to make characterization of complex hopping or modulation action easier. The combination of all these capabilities in one box makes the RSA 5000 a high-performance and powerful RF device characterization instrument for any lab or bench.